Before we worry about whether or not we're going to solve the system using elimination or substitution, I think it will make things seem a little bit more manageable if we get rid of the fractions. So the trick to getting rid of the fractions is to multiply the entire equation by the denominator. So I'm going to multiply the entire top equation by 7 because that matches the denominator here. So we're going to have to basically distribute this 7 to all of the terms in this equation. So this is going to turn into 7x minus 10y, and that's going to equal negative 21. Really quick up at the top, I just want to explain why the 7, let me use a different color, the 7 times 10 over 7y does what it does. Basically, this 7 and this 7 cancel each other out. Leaving you with just the 10 and the y that's left over. What's actually happening is if you multiplied, like this is 7 over 1, if you multiplied straight across, it's like 70 over 7, which if you reduce it is 10. So that's where that comes from. Basically the 7 that we're multiplying by and the denominator cancel each other out. So now I have no more fractions in the top equation. For the bottom equation, I'm going to multiply everything by 3. And again, I have to distribute it to all of my terms. So this is going to turn into 3x minus 2y equals negative 9. Okay, so I have, let me fix my y here. I have two equations that are in standard form. So in my opinion, the easiest way to do this is going to be by elimination. And I'm looking at the y's in particular. If I take 2 and I multiply it by 5, so if I multiply this whole equation by 5, it's going to turn this term into a negative 10y. So I'm almost where I need to be, but I do also need it to be an opposite sign, so I'll multiply by negative 5. So I am going to copy down the blue equation. I'm not changing anything. And now I'm going to rewrite the purple equation after multiplying everything by negative 5. Okay, so I'm going to add these two things together. My 10y's cancel, which is what I wanted. This would leave me with negative 8x. And then negative 21 plus 45 would be 24. Now we'll divide both sides by negative 8. And I get the first part of my solution, which is that x is equal to negative 3. Now I have to take this solution, or the part of the solution, and I need to plug it back in to one of my original equations to figure out my y value. Now my original equations have fractions in them. So if we plugged it in, it would work. But what we could do is we could use one of my equations up here where I'm putting this dark blue star. We could use one of those after we got rid of the fractions. That we could use that too. So I'm going to choose to use the purple one, the original purple one after I got rid of the fraction. So I'm going to take x equals negative 3 and plug it in. So it would be 3 times negative 3 minus 2 times y equals negative 9, which would be negative 9 minus 2y equals negative 9. Add 9 to both sides. So you'd have negative 2y equals 0, and then if you divide by negative 2, your answer is still 0. So final answer to this question would be the ordered pair negative 3, 0.